Hey, Sam here for Sam's Tank Talks. Quickly, we're going to run through how a tank is actually made, but to start, we want to show you where the concept comes from. That comes from engineer drawings. We have a fantastic engineer here who does all these drawings, which get approved by the customer, and then we actually put a full fabrication package that explains exactly how this tank should be built, how all the pieces should be put together, different weld procedures, how to physically assemble the tank. Take flat steel and turn it into something beautiful. Next, let's go look at how that's actually done. Let's take a walk. So, as I mentioned, all tanks, they start out as flat steel, just a piece of steel. I mean, all tanks start out as minerals in the ground, but eventually that gets turned into steel. Here at Mass Tank, we buy American steel, so all of this steel comes from foundries out of the Midwest through our distribution channels to here. So you're looking at a whole bunch of steel, different thicknesses, different lengths, depending on which tank this plate is going to. We typically buy plates specific to a job. It's just a little bit more cost effective that way. And our fabrication tolerance is within 1/8 of an inch, so we have to be pretty exact. And when you think about it, if you're making a cylindrical tank, you have to get a piece of plate that is the circumference of that tank, right? So again, depending on the specific tank it's going to, it will determine how long that piece of plate is. Once we get the plate, we always verify. We measure it on site to make sure that what we got is truly, what we ordered is truly what we got. If there is any discrepancy, typically they err on the side of having it a little bit too long, which we appreciate. You can't add steel if it's a little bit too short. But if it is too long, we'll actually use this machine here. This is called a shear. This will trim the plate. So again, our fabrication tolerance is to within 1/8 of an inch. We want to make sure that when we roll that steel plate into a cylinder, it matches the exact diameter that it should. So if the steel is a little bit too long, we'll put it through the shear just to trim a little bit off, make sure it matches that circumference length. From there, once the steel is trimmed to the appropriate length, it comes over here to the roller. Now this is the lifeblood of the company. You know, if this thing goes down, we stop working, because this is how every tank is made. This is our tank rolls, and what this does, as aptly named, is it rolls the flat plate into a cylinder. This machine is from 1945. We have mechanics here on staff just to keep this thing running. It's beautiful. This opens up. This entire arm levers up, and then the plate is slid in here. This arm will go down, and then our roller, we have one guy, he is an expert at this, he does a fantastic job, moves those rolls depending on the ending diameter of the tank. And again, it's an art form. So as he's rolling it, he'll tinker with those rolls to make sure it comes out to the exact diameter. Obviously, we don't want to roll the whole thing and realize we're off by a few inches. So what we have is over here, we have dies that correspond to each of the diameters of tanks we build. So as the plate is being rolled through, Devon will take a die and hold it against the plate, and as it's being rolled through, if that die is flush to the plate, we know the curvature matches the end diameter. So as it's coming through, he can assure it's the right curvature. He doesn't need to re-roll it and re-roll it. He just gets it right the first time. It's awesome. And to actually see what that looks like, we roll the plate. Once it's rolled, we tack weld it together so it doesn't unfurl. And this is what we end up with. A rolled plate. Now what's interesting here, this plate is going to be part of the 50,000 gallon tank that we're building. The diameter is bigger than the door, so we actually over-roll these things to tighten it up, weld them together, and then when we go to fabricate, they'll cut these tabs off, and this will unfurl to the proper diameter. It's a lot of figuring out how this stuff's going to work, especially when the tanks are this big. So once we have each individual piece, we call these cans. Once all the cans are rolled, then we start putting the tank together and we move into what's called fit up. So we take each one of the cans, each one of the rolls, and we start laying them up side by side. And again, this is why those diameters matter so much. If one can is 12 foot 1 inch diameter and the other one is 11 foot 11 inch diameter, they're not going to fit, right? So it has to be exact. It has to be exactly right. So they fit up all the cans, put them together. They'll just tack weld the outside just to hold it in place. Tack, tack, tack. Once the cans are fit up, the team goes inside, following confined space procedures, and they back weld all of the seams. So they weld inside the tank 100% of the internal seam. Then they come outside the tank. They'll grind those seams out. We might have an example down here I can show you. They'll grind those seams out and then start putting welds from the outside in, laying one bead in the middle and then layering beads on top of that as they go. It's a really long process. It involves a lot of labor, welding inside the tank, outside the tank, grinding, tacking. There's a lot to it. That's a good example of a back grind. So they've welded, now it's been ground out, and now they're going to weld into that groove. But again, it's a very labor-intensive process. Going in the tank, welding 100%, coming outside the tank, grinding 100%, welding, cleaning it up, cleaning the slag. It's very intensive, and you know, we really stand by our quality. We want to make sure when something's built, it's built right and it's built to last. And so that's why we go through this process. It may not be the quickest, but we're confident that it is the best.